So looking at the last couple examples, they want us to graph the triangle and then classify it by its angles and sides. So I went ahead and I graphed both triangles in the coordinate planes, and now it wants us to classify by angles and classify by sides. So we'll classify by sides first. So if we go to classify by sides, if we check out our list, how to identify in a coordinate plane, for all three, it says we have to use the distance formula, and we've got to use the distance formula for all three sides to tell the lengths. So if we do that, and we find the distance formula for AB is going to be equal to the square root of 0 minus 4 squared plus 4 minus 5 squared. So AB is going to be equal to the square root of negative 4 squared plus negative 1 squared. So AB is going to be equal to the square root of 16 plus 1. So AB is going to be equal to the square root of 17. And I'm going to leave it just like that. So square root of 17 is AB. Well, that's one of the sides. We need all three. BC is going to be equal to the square root of 4 minus 1 squared plus 5 minus 0 squared. BC is going to be equal to the square root of 4 minus 1 is 3 squared plus 5 minus 0 is 5 squared. So BC is going to be equal to the square root of 9 plus 25. So BC is going to be equal to the square root of 34. So this one right there, so that's going to be the square root of 34. And then last side, so AC, we need to know the distance from A to C. So we're going to have 0 minus 1 squared plus 4 minus 0 squared. So AC is going to be equal to the square root of negative 1 squared plus 4 squared. So AC is going to be equal to the square root of 1 plus 16. So AC is going to be equal to the square root of 17. And we're classifying by sides. So if we check our list, all the distances are different. And if you check, we've got square root of 17, square root of 34, and square root of 17. Those aren't all different. We have two that are the same. So if we check for the distance formula where all two distances are the same, that's going to be an isosceles triangle. So this is isosceles. And then it says classify by its angles. And if we're classifying by angles, the big one that we need to worry about is the right angle. If it's going to be anything math-wise, it's going to be a right angle. And for that one, we're looking for opposite reciprocals for the slope. That means we need to look at the slopes for all three of the different lines. And this one right there, I forgot to mark with square root of 17. So that means we need the slope of AC, AB, and CB. And just like I said right here, you can use that slope formula, or you can just count what the slope is going to be. Because if you remember, slope is rise over run. So you start at a point, you count how much you go up or down, and then you put that over how much you go left or right. If you go up, it's going to be positive, down is going to be negative, left is going to be negative, right is going to be positive. So if we do that here, and we'll do our slope for AB first, we're going to start right here, and we're going to go up 1. So that's a positive 1, and then we're going to go over 1, 2, 3, 4. So the slope for AB is going to be 1/4. We need the slope for all three to be able to compare. So then the slope of BC is going to be equal to, well, to go from B to C, we have to go down first. So 1, 2, 3, 4, 5. So down 5, and then over 1, 2, 3. So down 5 and over 3, and we went to the left, so it's negative. So our slope for BC, if we simplify it, is going to be a positive 5/3. Okay. and then doing the slope of AC. The slope of AC, if we start at A, we're going to go down 1, 2, 3, 4. So down 4 and then over to the right 1. So our slope for AC is going to be -4/1. And then here it says if we have a right triangle, two sides are going to be perpendicular. And it's going to be their slopes are going to be perpendicular. So that means we need to check for opposite reciprocals. So if we look between AB and BC, those are not opposite reciprocals. And then BC to AC, they're opposite, but they're not reciprocals. The fractions haven't been flipped. But if we look from AC to AB, there's a positive, there's a negative, there's a 1/4, and there's a 4/1. So those are opposite reciprocals. So it means they're perpendicular, which means we have a right triangle, and so this one can be classified as a right isosceles triangle. If we look at the next one, again, we're classifying by angles and sides. So in order to be able to classify by angles, we would have to know the slopes for all three. So if we do the slope for AB, start at A, go to B, we go 1, 2, 3, 4, 5 down. So -5 over 0. And if you put this in your calculator will give you some kind of an error measure or error message. See how it says error, or it'll say undefined or no domain. Pretty much if you end up with this, that means the slope is going to be undefined. And the only thing that would be an opposite reciprocal for undefined would be a 0 slope. So one of the slopes would have to be 0 with AB in order for that particular angle, either right there or right there, to be 90 degrees. So then doing the slope for BC. So if we start at B, we've got to go up 1, 2, 3, 4. Up 4, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we simplify that, and whenever you're looking and comparing slopes, you're always going to want to simplify your fractions. So the slope for BC simplifies from 4/10 to 2/5. So those two aren't opposite reciprocals. And then the slope of AC, so starting there, going down 1, going down means we have a negative, and then over 10. So if we look and we compare all three of the slopes, none of them are going to be opposite reciprocals, so this is not a right triangle. So then it's a matter of just checking out the list. Are all of the angles less than 90 degrees? Well, if we look, can we make a box there? If we made a box here, that would make this be 90, and it's not, so it's less than, so that's not a right angle. Same thing here. You can also check with a piece of paper, and it goes behind, so it's going to be less than, and same thing for that right there. So this triangle is going to be acute. So we've classified by the angles. Now we need to classify by the sides. And in order to classify by the sides, we need to use the distance formula and then compare to see if we have any that are the same. So if we do the distance formula for A to B, that's going to be equal to the square root of -6 minus a -6 squared plus 1 minus -4 squared. So AB is going to be equal to the square root of 6 minus a -6 is going to be 0 squared plus 1 minus a -4, 5 squared. So AB is going to be equal to the square root of 25. So AB is going to be equal to 5. And yes, since it's a vertical line, we could have also just counted that it's 5. 1, 2, 3, 4, 5. Yep. So then looking at BC, BC is going to be equal to the square root of negative 6 minus 4 squared plus negative 4 minus 0 squared. So BC is going to be equal to the square root of negative 6 minus 4 is a negative 10 squared plus negative 4 squared. So BC is going to be equal to the square root of 100 plus 16. So BC is going to be equal to the square root of 116. And then last we'll do AC. AC is going to be equal to the square root of negative 6 minus 4 squared plus 1 minus 0 squared. So AC is going to be equal to the square root of negative 10 squared plus 1 squared. So AC is going to be equal to the square root of 100 plus 1. So AC is going to be equal to the square root of 101. So if we're looking at our side measures, we've got AB equal to 5, BC is equal to the square root of 116, and AC is equal to the square root of 101. So these are the lengths we're focusing on right there. And if we look, none of them are the same. So that's our angles. Here's our sides. So all distances are different, and that qualifies as a scalene triangle. So we have an acute scalene triangle. So there's a couple examples for how to find and classify triangles in a coordinate plane based on their angles and sides. If you have any questions, make sure to write them down on your guided notes and ask when you get to class.